Vector summation and calculus. Vector summation and calculus, the arena in which we are pursuing the discussion. Can I divide my problem into n different parts, solve part by part, and then sum it? If someone thinks that part by part is not sufficient in a way that if n is a fixed number, then calculation may not be accurate. Then someone is free to make n tends to infinity. If someone is summing, this is a problem. Dividing the problem into n different parts. Solve part by part and sum it. While summing it, like sigma I equal to 1 to n, means each I is the solution of one part. Summation sigma I equal to 1 to n. Part ith solution. If I add for all, I get the net solution. What about this is not accurate? Okay, there can be scenario where it is not accurate. Then we will proceed as n tends to infinity. When n tends to infinity, expectation that this would be accurate. If n tends to infinity and I have a summation of n item, then I have to bring it to integral calculus. Directly bringing to integral calculus may not be possible because integral calculus is repeated summation of sub area. Integral calculus calculates area. If this is x-axis and this is the graph, this is x-axis, and this is a graph called function over x. If I do fx dx, it calculates area underneath it. If this is xy plane and I have function over xy, that is a surface, fxy dx dy or dxy will calculate volume underneath it. If this is x-axis and this is function over x-axis, fx dx will calculate area underneath it. Okay, if I have the repeated summation of sub area, non-overlapping sub area, okay, n, where n tends to infinity, then this can be a fit case to convert it to integral calculus. Otherwise, if it is not a repeated addition of sub area means length into width. This is also called sub area. Height into width is called sub area. Repeated addition of sub area, if that is not the case, repeated addition of single item is there, not the dual item. We need dual item, vertical into horizontal. If repeated summation is there for the dual item, then someone can dual item, then someone can proceed in the integral calculus. Otherwise, someone has to convert the single item into dual item. Then someone has to convert a single item into dual item. Okay, that is the concept. Then it will be single item means summation I equal to 1 to n, and some item is there that is single item that has to be converted into something into delta x. Vertical into delta x means if I chop this x-axis into n different parts, each part has a width of delta x. Delta x into the height, this is sub area. Adding all sub area can be integral calculus. If I have summation of only vertical, not multiplied by the horizontal, then someone has to calculate in that fashion. Anyway, this is the concept. What we are trying to do now, where n tends to infinity when it is required. It is required like I am hope gone. Okay, the concept is where it is required. If I have a circle, okay, if I have a circle and I am trying to compute the circumference of the circle, I chop the circumference of the circle into n part. Make sense? The circumference of the circle into n part. Then I calculate one part circumference, but calculating the one part circumference is not possible. I connect begin point and end point like a straight line, and calculate the length. Then a straight line, calculate the length. Okay, if I divide into n part, it will give the circumference but approximate, because I have taken one part and calculated the straight line length, not the curve length. So circumference will be approximate. It will not be the accurate. In that fashion, I have to divide the circumference into n part. N tends to infinity. If n tends to infinity, then one section will tend to 0. If this length is 0, then its curve will be like a straight line. Then it will work. There we need to convert n tends to infinity. Anyway, we are in phase of calculating the surface area of the circle. What is surface area of the circle? Okay, consider this circle falls in xy coordinate. The circle falls in xy coordinate. This is x-axis and this is y-axis. This this is x-axis and this is y-axis. Okay, this is x-axis and this is y-axis. Now I have a circle like this. I have a circle like this. Can I compute the area of the circle? Okay, to compute the area of the circle, now we went with a new technology called r theta plane. This is xy plane. This is xy plane. This is origin and this is circle. Equation of the circle is x square plus y square equal to a square. A square is the interception on the x-axis. A is interception on the y-axis. This length is a. X square plus y square equal to a square is the equation of circle. What is area of the circle? Then I took another variable called r. What is r? R is x square plus y square equal to r square. This is what I am considering. Okay, or x equal to r cos theta, whatever it comes handy. I have taken another coordinate system called r and theta, where r square equal to x square plus y square. Theta equal to tan inverse y by x. Theta equal to tan inverse y by x. Okay, what do you mean? Y by x equal to tan theta and r square equal to x square plus y square. In reverse manner, x equal to r cos theta and y equal to r sin theta. I took two coordinate systems. This is one coordinate system. This is one coordinate system and this is another coordinate system. This is xy coordinate system and this is r theta coordinate system. Different. Okay. In r theta coordinate system and xy coordinate system. Consider in r theta coordinate system, I have variation in theta, whereas r is vertical and this is horizontal. Vertical is always a. Vertical is not changing. Radius is not changing. Vertical is always at height a, always flat line. There is a flat line called a, and theta varies from 0 to 2 pi. Theta varies from 0 to 2 pi. Okay, r varies 0 to a. R varies 0 to a. I'm sorry. Hop. Now this is theta r plane and this is xy plane. In theta r plane, theta is varying 0 to 2 pi. This is radius axis, this is theta axis. Radius is always constant at a. It is a flat line. It makes a rectangle. It makes this is V. Okay, so now concept is that in theta r plane, what we are talking in theta r plane, I have a rectangle. In theta r plane, I have a rectangle where the r is constant, that is a, and theta is going from 0 to 2 pi. Okay, if I take exactly, this is theta r plane, exactly mapping of the shape in xy plane, this is x-axis, this is y-axis. This will be a circle centered at the origin and radius a. This is a circle centered at the origin at radius a. This is xy plane. If I take this mapping of xy plane into theta r plane, it will be a rectangle. It will be a rectangle of height a, constant height a, and width is 0 to 2 pi. This is the relationship because x equal to r cos theta and y equal to r sin theta. Or in xy plane, if this is a circle, then x square plus y square equal to r square. That is the equation of circle only. Means which has a radius of a, x square plus y square equal to a square, which has radius of a. Okay, and then y by x, any moment. If y by x means if I take any moment, y by x, any moment. If I take this as x, take this as x, it go and hit here. This is y and this is x. Y by x. Okay, what is y by x? Y by x can be called as tan theta. What is tan theta? If I take that point, I take any point here. This is x and this is y. This is y and this is x. Y by x is tan theta. Tan theta. Okay, means theta equal to tan inverse y by x. This is what we are talking. I have taken another plane as theta r plane and one plane as xy plane. Relationship is theta equal to tan inverse y by x and r square equal to x square plus y square. If I have a circle in xy plane, then certainly the equation of the circle is x square plus y square equal to r square only. Means whatever I have taken relationship between r theta plane and xy plane, that relationship, if there is a rectangle in r theta plane, that will exactly map to a circle in xy plane, which is centered at the origin. That is the main thing. And its radius is a. Okay, then in theta r plane, it will be like this. The question is arising that how I can compute the area of the circle. There are two shapes now we are talking now. One is circle in xy plane and one is rectangle in r theta plane. What is the area of the circle in xy plane? In r theta plane, there are many ways we have talked already. I believe three ways we have already done it. Three ways. This is fourth way. Okay, if I have a rectangle in xy plane from 0 to 2 pi theta and 0 to a, I chop the theta into n part. I thought I chopped the a 0 to a this side into m part. Okay, m for mountain. I chop into m part and I chop into n part. I have m into n rectangle. I have m into n rectangle. If I have m into n rectangles, then one rectangle width is 2 pi by n, and that rectangle height is, width is 2 pi by n and height is a by m. That is the height. What is the area of this rectangle? I say this rectangle as ith jth rectangle. Means if this is 0 to 2 pi theta, I chop into n part. This is the first part, second part, ith part. Similarly, first part, second part, jth part. I am talking about a small rectangle that is I comma j. There are m into n rectangle, sorry, n into m rectangle. I am talking about the rectangle that is I comma j, whose width is 2 pi by n and height is a by m, where radius is fixed a. If I map that section, if I map that rectangular section in this in the Cartesian coordinate system, then how it will map? Okay, if I map in Cartesian coordinate system, then I said there is a, now if I say there is a ith jth section of sub rectangle, if I say ith jth section of that sub rectangle, this is a sub rectangle. This is the rectangle. And then ith section and jth section. Consider that point begin of the, if this is ith section, this is begin of the ith section, end of the ith section. Consider this is at theta. Then the gap is delta theta I. This is at theta plus delta theta I. Similarly, if this is the jth section, if this is the begin of the jth section, consider this length is r. Then this is delta rj. This is r plus delta rj. So the sub-rectangle we are talking, we have taken ith jth. It has a width of delta theta I and height of delta rj. The left bottom corner is theta comma r. Okay, if I talk theta comma r here, if I talk theta comma r in the xy plane, this is xy plane and circle is there. Theta comma r, if I talk in theta comma r, then this is r, this is theta. First I have to move it like this, theta, because relationship is clear. Theta is the angle. If I take one line and then attach it to origin and move the line like this will be the radius and this is theta. I'm doing it in xy plane. The relationship, if I draw together, xy plane and theta are plane together, then r will be like, move like this and radius will be like this. This is radius will go like this and angle will move like this. This is the relationship. If I say that I have a sub-rectangle in theta r plane, bottom left corner is theta comma r, then this is theta and this is r, not full A. This is A, full radius. This is r at any r, theta. Now I am moving in theta. I am moving the theta to delta, theta plus theta. Now in the theta r plane, in theta r in theta r plane, I have a subrectangle. I have a rectangle, and there is a subrectangle. In ith jth section, bottom left is theta comma r. If I move like this, then I keep r constant, and then I move like this, then it is delta theta width. That this point will be r comma theta plus delta theta I. If I move vertically where theta is constant, the new point is r theta. I'm sorry, theta comma r plus delta rj. Similarly, in xy plane, if I have noticed that this is the point I have moved theta. Theta will go 2 pi, and this is the radius. Radius will go 0 to a at r, any r, and at any theta. This is the point. If I move theta like this, where r is where the radius is constant, from here theta to delta theta I have moved. Now this angle is theta plus delta theta. This angle is theta. I move like this. Now this is delta theta, where I keep radius constant. It make an arc. Okay, arc means this point on the arc is r comma theta comma r, and then this point is theta plus delta theta comma r. Similarly, now if this is theta comma r, then I move along radius making theta constant, where theta will not change, radius will change. This is delta r. R will go from one point to another point delta r. If this is theta comma r, then this is theta comma r plus delta r. Okay, then this is the strip we are talking that correspond to ith jth section in the subrectangle. This is the strip. What is the area of this strip? If I know ith jth section area of the strip, okay, this point is theta comma r, though it is not theta comma r. If I take in xy plane, then this point is not theta comma r. In xy plane, this point will be this is theta. This point will be theta r comma r, because theta is angle and r is length. If I talk about any point, then it will be theta r comma r. But let's, for simplicity, take theta comma r. If this point is theta comma r, keeping r constant, I move delta theta. So it moved like an arc. Then keeping theta constant, I move along r. It is a straight line. Now one straight line and then arc. This is the section that corresponds to the rectangular, sub-rectangular region in theta r plane. That is delta theta delta r. That is delta theta delta r. In the theta r plane, we have sub-rectangle. In theta r plane, we have a sub-rectangle. In theta r plane, we have a rectangle where r, that is a, is constant and theta is varying. Constant means height is constant everywhere. If I vary in theta and then check what is the height, then everywhere it is a. Everywhere it is a. If I have a, that is the y-axis or r-axis. If I have a, every moment I check what is theta. Theta is varying. Theta is not constant. Theta is going from 0 to 2 pi, where it is constant. If I see relative to the theta axis, then A is constant. Everywhere vertical is constant. Everywhere. Someone can think relative to the R axis, but relative to the theta axis, height is always constant. So it is a straight line. Then it is a rectangle. Then I chop this horizontal axis into n part and vertical axis into m part. And then I took ith part and jth part to make a small subrectangle. This small subrectangle that corresponds to I comma jth, this small subrectangle that corresponds to ith comma jth, that ith comma jth, which has a width of delta theta I and delta rj, that will correspond to a section like this, arc section in the circular region, that is ith comma jth. If I add all ith comma gth all, it will become the area of the circle. Makes sense? There it is quite easy. Since it is a rectangle, you add for all, you get the area. But that will be a rectangular area that I don't want. Mapping of this rectangular area with the mapping function, that is x equal to r cos theta, y equal to r sin theta. This rectangle in theta r plane will become circle in xy plane. Okay, that mapping of that small sub-rectangle delta theta I delta rj will map into an arc section in this. If I add summation I equal to 1 to n, summation j equal to 1 to m, area of the ith jth arc. If I add for all, then I get the area of the circle. Okay, what we have done till now? We did many things to calculate this. One thing we took, if I describe all three way we have done right now. One way we took, if this is arc, if this is the arc, if this is x-axis and this is the radius, if this is the arc where radius is constant, it is moving like this. This is point P, that is theta comma r. If it moves like this, then there is another point called P1. So this is P, this is P1. This is the arc. If this is P, then if I move along radius keeping theta constant, this is P2. If I do cross product of this arc and this line, then it will give area in between as per the nature of cross product. If you have two vectors, if you calculate the cross product of two vectors, it gives area in between. Okay, in that fashion, I have to find the vector representation of this arc and this one. This is easy. This is delta r unit vector. If this point is theta comma r, this point is theta comma r plus delta r. If I draw a vector in polar coordinate system, then it will be delta r unit vector. If this point is theta comma r and this point is theta plus delta theta comma r, if I subtract, it will give me another vector. That will be delta theta. Okay, but as I said that if I try to draw polar coordinate system, if this is polar coordinate system, theta and r, each point will be theta comma r. But if I try to draw polar coordinate system in xy plane, where this is the radius and this is theta, then each point will be the theta will be represented through the arc, because I need distance. If I set any point in the xy coordinate system, then theta will be converted into theta into r. That will be r comma r. That is the point in polar coordinate system inside Cartesian coordinate system. It cannot be theta comma r. If I say I have any point in Cartesian coordinate system where polar coordinate system is superimposed as theta comma r, that is false, because theta is angle and r is distance. Theta part has to be distance also. In that sense, it will be theta r, that is the r. So if this point is theta r comma r, this point is theta. This point is theta plus delta theta comma r. If I take a vector, it will become r delta theta unit vector. R will go away. The way I took this point along the radius, then theta went away. Now I have cross product of delta r unit vector cross product r delta theta unit vector. But problem here is I have taken a straight line. If someone remembers, I have taken a straight line connecting this point and this point. I should have taken a vector representation of a curved line, not a straight line. To solve this, we divided theta angle into n parts. Then we made n tends to infinity. If I make n tends to infinity, then this movement of the delta theta will be so small because I chopped this angle into two, that is 2 pi into n parts. Each part is so small, n tends to infinity, that the movement will be so small that arc and a straight line will behave the same. Then it will work. Anyway, what we can do other fundamental. So now we have r delta theta delta r as the area of the one section, that is ISJS section. If I add for I equal to 1 to n, j equal to 1 to m, n tends to infinity, m tends to infinity, n tends to infinity, m tends to infinity. If I add in that fashion, then it becomes a full-fledged integration. It gives the area. What else we want? Where we are lacking now? We are lacking because if I take the arc region, that the way we are talking, we have a arc region, arc region. Consider this is the arc region. Okay, this is the arc region. This is the one arc, and this is the second arc will go like this. This is the arc region. This is delta r. Okay, and this is the line that is going connecting two points. If this point is at angle theta, then this line is at angle theta plus delta theta. So angle between these two lines, the angle between these angle between these two lines, this angle is delta theta I. So I have to find the vector representation of this and vector representation of the radius. If I get a smooth vector representation, not the straight line vector representation. Straight line vector representation we have calculated. How we calculated? If this if this is the arc we have taken, sorry, this is the arc we have taken. If this point is r comma theta r or theta r comma r, if this point is r comma theta r, and if I proceed like this keeping r constant, then this point is r comma r theta plus delta theta. Okay, if I connect these 2 points through a vector that is a straight line, then I have to subtract these 2 points p and p1. It will become r delta theta theta unit vector. But is it possible that I take this smooth curve line as a vector? Is it possible? Yes, it is possible. This is our invention. It is not available in any of the book. Can I represent? Anyway, it is there, but how we can? This is called length vector. Can I represent a curved line through vector? Vector means you connect 2 points and a straight line is the vector. Can I represent this curved line through vector? To represent a curved line through vector, we have to understand what is difference between a curved line and a straight line. We have a full series of length vector. What is difference between a curved line and a straight line? A straight line division work. There are two concepts in mathematics. One is called division and one is called differentiation. Both are similar. One is called multiplication and one is called integral calculus. Both are similar. Okay, one is fx into x, that is multiplication. Fx into dx is integration. Y by x is division. Delta y by delta x or dy by dx is differentiation. Fx into x is the multiplication. Fx into delta x is integral. Y by x is division. Delta y by delta x is differentiation, where delta x tends to 0. Where it is useful? It is useful. Consider that I have a x-axis. I have x-axis and there is a straight line. There is a straight line. Okay, tell me what is y by x. Then take any point x here, see the y, and then divide it y by x. No, no, no. I said y by x at any point x1. Tell me. Okay, this is y by x. Now any point x2, tell me what is. Same. It is straight line, so y by x, everywhere y by x is same. So someone is finding, this is called linear equation. The equation of this line is y equal to mx, where m is constant. Y equal to mx, where m is constant. Everywhere y by x is m, and that is constant. So I can describe the y by x as a numerical number. That is division. Division will work here, no problem. But if it is not a straight line and it is a curve line, if it is not a straight line, it is a curve line. This is y equal to x square. This is y equal to x square. If it is y equal to x square, then what is y by x? Then you tell me at what point you want y by x. Because everywhere y by x is different. When x is 10, then y is 100. When x is 2, y is 4. When x is 5, y is 25. Y by x is different at different points. What do you mean? I mean that this curve line is a series of straight lines. Means at this point, if I see, then there is a straight line going like this. This is also called tangent line. If I see this point, there is a straight line going like this. Every moment, the line is changing its direction. At a particular point, what is the line direction? That will be a straight line that is passing that point. But every point, the straight line that is passing the point is different. Then what is y by x? You have to tell me at what point you want y by x. Y by x is not constant. Okay, tell me y by x at point x1. Okay, understood. That you want. Okay, so this is x1. Okay, I go hit here. This is the point. This height is y1. This point. At this point, let's find out what is the line that is passing through this point x1 y1. If I find that line, for that particular line, what is y by x? This is what you want, right? Yeah, this is what I want. What is the y by x at point x2? This is x2. Go up and hit it. This is y2. This is x2. At this point, find the equation of the straight line that is passing here. If it is a straight line at that point, then calculate y by x of the. It means that there are infinite straight lines passing through this. Yeah, there are infinite. At every straight line, y by x is different. This is differentiation. What is differentiation? If I want y by x at a particular point, y by x at x equal to x1, this is denoted as delta y by delta x. Y by x at any point, it should be constant. If it is constant, then this is division. Y by x at different x, it is different, then this will be addressable through differentiation. What is differentiation? If I take any point x1, if I go hit this here, then there is a straight line. Minute straight line is there. For that straight line, take one small strip called delta x, and then accordingly there will be a small strip called delta y. What is delta y by delta x? Or at that point, calculate the equation of the tangent line, then leave it. Have the tangent line. Make the tangent line proceed and touch the origin parallelly. This is tangent line. At that moment, then calculate y by x. It is same as if I take the curve and at any point x1, if touching the curve here, then at this point take a minute length, considering it is a straight line. For that, take delta x and delta y. If this point there is a minute straight line like this, then this much is the length of the straight line I have taken. That is very small. Then this is delta x and this is delta y. Delta y by delta x. That is the y by x at that point. That is also denoted as delta y by delta x, where delta x tends to 0, because momentarily I am calculating the straight line. This is differentiation. Okay, delta y by delta x tends to 0 is differentiation. Means dy by dx. dy by dx will come as algebra. Algebra means you keep changing, like y equal to x square. dy by dx equal to 2x. You keep changing value of x, you will keep getting different y by x. If y equal to 2x, then y by x equal to 2, or dy by dx equal to 2. Differentiation is superset of division. Division is already there. 2 means constant. You take any x value, that the y by x will be 2. But if it is y equal to x square, then dy by dx, y by x will be y. If it is y equal to x square, then y by x will be x. y by x, where y is x square, y by x will be x. dy by dx will be 2x. Okay, 2x means keep changing value of x and you will get y by x differently. When x is 2, then y by x is 4, not x, the way we are saying. As per division, division is will fail here. Division will give full division, full division from the origin. If this is x equal to 2 and this is 4, then it will 4 by 2. Okay, this line, if I connect this point to origin, this line y by x it will give. I don't want this line y by x. There is a hole in between. I want at this point the tangent line y by x, not this line. If I take division, if I take x equal to 10, this is 10 and this is 100. If I take division, that is x square by x is 10, then it will connect this point and origin. This point slope it will give. That I don't want. I want this point slope, the line that is passing here. That is the differentiation. Anyway, so for differentiation, if I have a curved line, then y by x is different at different points. If I have a straight line, then y by x is constant. So y by x is variable. If I want to represent anything through mathematics, I must take care of the variable. It must be there. Okay, if I connect origin, if I connect this origin and any point x comma y, any point, what is the vector representation of this line? This is 0, 0, and this is x comma y, xi plus yj. If this is a straight line, and this point is x comma y and this is origin, what is equation of this line? It is xi plus yj. I can say the length vector of this line is xi plus yj. But if it is a curve line, then I cannot say length vector of this point at this point, that is x comma y is xi plus yj, because it will be this vector. That I don't want. I want this vector, different at different. If you want different vector at different point, then you have to get one variable that is different at different point. What is that variable? That is y by x. Y by x is different at different point. So if I say I have a point x comma y, I want to represent this line through vector. That is the concept. How I represent a curved line through a vector? If I have a straight line, I take any point here x comma y and origin, I can represent this straight line in xi plus yj. It will work. But if I take a curved line, if I take any arbitrary point x comma y, then I'll connect from origin. This will be xi plus yj. That will not work. What it will work? Xi plus yj. Let's take out x. Then it becomes I plus y by xj bracket into x. I plus y by xj bracket into x. Y by x came into the picture because that is variable. Okay, now this division I have to convert into differentiation if I want momentarily. But what if it is not a curved line? Still it will work. Division is subset of differentiation and multiplication is subset of integration. So it will anyway work. Can I solve all problem multiplication through integration? Possible. Can I solve all the division through differentiation? Possible. Can I solve all the division through differentiation? Wrong. It may be wrong. Okay. But everything can be solved through integration and differentiation as far as multiplication and division is concerned. So I plus y by x I can write as I plus delta y by delta x. Makes sense? Because we saw that y by x at any point is perfect if I see delta y by delta x. If that is the case, then I transform it as I plus delta y by delta x j and in bracket into x. Now this multiplication I'll convert into integral calculus into delta x. This is called vector representation of a curved line. Actually, it starts from xi plus yj only, but I have to transform this xi. This is xi plus yj. I have to transform this xi plus yj into actually this vector, not this vector, this vector. To transform this, first I brought it into y by x and change y by x to delta y by. This is our way. So length vector of any curved line is I plus delta y by delta x j bracket close into delta x, or someone can say I plus dy by dx j bracket close into dx. This is the length vector of any curve that can be used anywhere. Let's try to find out the ISJS section area that we were in discussion. Okay, now this is the area strip we are talking. Area strip. Now can I find vector representation of this line and vector representation of this curve line? If I do cross product, I'll get the area of the this strip ISX. What is vector representation of this line? What is vector in the polar coordinate system? Polar coordinate system, there are 2 points. One point is R and one point is theta comma R. R and theta comma R. Vector representation is R R unit vector plus theta R theta, where theta is variable, R theta unit vector. What would be the length vector then? Okay, what variable you want? Okay, in my case if I take like if I take like this, then variable is R, then take out R. If you take out R, it becomes R unit vector plus R theta by R theta unit vector bracket close into R. What about this curve? Yeah, what about this curve? This curve. This curve, theta is variable. I have to take out theta from same thing. Then it becomes R by theta, R unit vector plus R theta by theta unit vector, bracket close, theta. I have to do cross product of these two. One is both R unit vector plus R theta unit vector. Both vector are like this. One R is variable and another theta is variable. So I have to take cross product of two vector where I'll take out R from one side and theta from another side. If I take R out from one side, then it will become R unit vector, R by R unit vector, means R unit vector plus R theta by R theta unit vector. Theta is not varying here. Theta is not varying. This will be 0. R unit vector. Sorry, R unit vector. Cross product. Now in another section. Cross product in another section. Another section. I'm sorry. It is okay. What it is? I'm sorry. R unit vector. R unit vector plus R theta unit vector. I have taken out R from here. It becomes R by R unit vector plus R theta by R theta unit vector, bracket close, into R. Cross product, from that side I have to take out theta. Then it becomes R by theta, R unit vector plus R theta by theta unit vector, bracket close, into theta. Now convert into calculus. So wherever division is there, make it delta, and wherever multiplication is, make it delta. So first is theta by R, that is 0. And another is R by theta, that is 0, because this side theta is not varying, and this side this side, if I take this R is not varying, this side theta is not varying. So first will become R unit vector, just R unit vector. Another will become R. Another will become, I'm sorry, R unit vector into R. So into R, I'll rewrite this. I have cross product of two vectors. One vector is going along radius direction where theta is constant, and one vector is going along arc direction where r is constant. So in this vector is r unit vector plus r theta unit vector. This vector is also r unit vector and plus r theta unit vector. Here r is independent, take out r. It becomes r by r unit vector plus r theta by r theta unit vector. Bracket close into R. Cross product, take out theta from here. It becomes R by theta, R unit vector plus R theta by theta unit vector outside theta. Okay, now the first one, wherever the division is there, convert into differentiation, and wherever multiplication is there, convert into integral calculus. So it will become delta R by delta R unit vector plus or delta theta by delta R, theta unit vector, bracket close. This is full function into R. It will become integral calculus into delta R. Okay, cross product. Next is delta R by delta theta. This was R by theta. So delta R by delta theta, R unit vector, plus R delta theta by delta theta, theta unit vector, bracket close, into theta, into delta theta. Now dr by delta theta by delta R is 0, and here First side, delta theta by delta r is 0 because theta is not changing. And this side, r is not changing. Now it will become delta r unit vector. Cross product, cross product with r delta theta, delta theta, theta unit vector. If someone do the cross product, it becomes r delta theta delta r. What is delta theta and delta r? What is delta theta and delta r? Actually, it is r d theta dr as per the calculus. Deliberately, I have taken delta theta delta r. Consider delta theta delta r must be, if I have converted it to differentiation and integral, any multiplication fx into x can be converted into fx into delta x provided delta x tends to 0. Any division y by x can be converted to delta y by delta x provided delta x tends to 0. When I have changed r by r to delta r by delta r theta by r to delta theta delta r, and this side r by theta to delta r by delta theta and theta to delta theta by, then denominator, and then first was multiplied with the r. I changed it to multiplied into delta r. Second was multiplied with the theta. Then I changed it to multiplied by delta theta. If I do like so, then the delta should tend to 0. Now at the end we came as r delta theta delta r, where delta r must be tends to 0. Delta theta must be tends to 0 whatsoever. Now how I can map it? To map it, now consider, then this is the, with the x-axis, this is at angle theta. This is the delta theta it moves. It must, okay, the delta theta what we are talking, let's it maps to this delta theta. And delta r what we are talking, it maps to this delta r, that is the jth section delta r. And this is the ith section delta theta. Means these two must be 0, must tend to 0, means that n division what we have made, n must be infinity, and m division what we made, m must be infinity whatsoever. What is the net area now? Summation I equal to 1 to n, n tends to infinity. Summation j equal to 1 to m, m tends to infinity. Okay, area of the this strip, and this strip area is r. This is r plus delta r, r. This will go from 0 to a. R delta theta I, this is delta theta I tends to 0. Delta rj, okay, this is the area of the ith section. Now sum it. Someone can bring it to integral calculus. What we have now? R delta theta delta r. Delta theta delta r can be rewritten as delta theta r. R can be rewritten as function over theta r. Function over theta r, delta theta r. It is the area of one subsection. If I add for all m and m, it will give integral calculus. Please watch our previous video. Then it can be written as integration of theta comma r from one limit to another limit. And then function over theta r, delta theta r, d theta r, d theta dr, because theta and r are orthogonal 90 degrees. So it will become r d theta dr. What is theta r? If I go back to if I go back to the if I go back to the theta r plane, then this is the If I go back to the theta r plane, then this is the rectangular region. Okay. If I go to our theta r plane, then this is a rectangle. This is a rectangle. So it will be integrable through this rectangle. What is integrable that we have talked? Let's consider this is theta and this is r. This is theta r plane. This is theta r plane. Tilt it like this. Okay, now I have integration theta r from one location to another location. Function over theta and r, that is r. D theta dr means it is looks like that function over theta and r. If this is theta and this is r, I make tilt it like this, then this is theta r plane. Function over theta and r means 3D. There is a surface called function over theta and r. If I say f function over theta r, d theta dr, we are trying to calculate volume of that surface. That volume of that surface where theta r will go from one location to another location. Means this is theta r. I have to calculate the volume for the set of point in theta r plane that is in a particular region. Make sense? If I am trying to calculate volume of a sphere, consider there is a sphere. This is theta axis and this is r axis. There is a sphere that is described as theta and r. If I integrate that sphere surface with d theta dr, what theta and r I have to take in the limit? Where this sphere hit this theta r plane. If there is a sphere, it intersect theta r plane. Probably it will intersect in a circular manner. Then I have to take all the x, y, theta r point in this within this circle only for the integration. If I am integrating f theta r d theta dr in this concept in theta r plane, there is a rectangle. So I have to integrate, I have to take all theta r within this rectangle only, not outside. So theta will be 0 to 2 pi and r will be 0 to a. Function over theta is r d theta dr. R d theta dr 0 to a, 0 to 2 pi will give the area of the circle. We will proceed on this. What about radius is variable with theta? R equal to cos theta sin theta. If radius is variable with theta, then how will we'll go with the cross product where we have thought r is constant and theta is constant. Then how I will take the cross product to come to the solution? That we will see. Amazing, mind-blowing, head-hitting in the wall. Please do not mind support. These explanations are not available in any of the book. Certainly. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.